Hello and welcome back to the channel. It's a pleasure to have you here. I really appreciate those that are subscribing and stay tuned because there's so much more about Berlin. So finishing day 3 of Web3 Summit and starting day 4 was the conference called DAppCon. DAppCon, as the name says, was a conference about Dapps, those decentralized applications. It was a pleasure to meet so many good developers that are helping to change the world with their applications. Luis Schlieske and Maximilian Orth, both members of Gelato team, were discussing how automated, trustless Dapp interactions are going to happen in the future.
What we try to do in our approach is to combine good UX with all the benefits of decentralization. We think that decentralization is non-negotiable, otherwise we wouldn't be here at DAppCon, I guess. So the user only talks to the Dapp interface and doesn't need to worry about gas prices, gets charged a fixed rate and has a service guarantee from the interface. The Dapp interface stakes on Gelato core to pay executors and pools the funds in kind of like an insurance scheme and therefore must charge a profitable fee in the long run. And it assigns users to single executors. The core is an escrow between interfaces and executors and requires interfaces to have a balance in order to pay executors, and it slashes executors for inactivity or for gas overpricing. And executors stake on the core to be accountable and incentivized. They get paid by the core if they act honestly, and they get slashed if they act dishonestly, and users get assigned to them by the interface, so there's no more collisions and racing conditions for them. So let's look at an example how this would look like under the hood with the example of refinancing a loan. So executors would stake on the core and so would interfaces to register themselves, and the user would then go to a front-end interface and approve funds to be moved and activate some triggers under which conditions the funds shall be movable. And then the interface mints some execution claims on the core and selects an executor for the user. When the user event actually happens on the Dapp, so for example in this case the interest rate of DYDX shoots over the one on compound, the executor then sends the trigger transaction and forwards the core forwards the call to the interface. The interface does all the Solidity smart contract checks like checking on-chain data, verifying that the event actually happened. And then if it did happen, it triggers Dapp interaction 1, withdrawing funds from compound for the user and automatically also depositing them on DYDX. At this point in time, the user's loan has basically been refinanced for a higher interest rate, all automatically. The user didn't have to do anything manually. And also, of course, the executor gets their payout from the Dapp interface balance. So there's a lot more things you can do with that other than just refinancing loans. You could think about limit orders on Uniswap. This would be the first time that we actually have limit orders on a fully decentralized exchange in a fully decentralized way. You could also think about time-based sell orders like we're currently working on with Gnosis for the Dutch X, where users can have their sell volume automatically spread across a lot of auctions without having to be there every time in order to send a transaction. Let's dive a bit deeper into some technical or game theory details here. How do we actually want to incentivize executors to have uptime and to use fair gas prices? It's a bit tricky. We have users assigned to executors, and we have the user trigger event where the executor must then execute within a buffer period. So there's an uptime challenge where challengers, this can be anyone really, can send a transaction, and if the executor's transaction is not mined within the buffer period, the challengers have succeeded in proving that the executor was inactive, and the executor's stake gets slashed and redistributed to the challengers. However, if they don't challenge, or if the executor's transaction does get mined within the buffer period, the executor should get their payout. There's also a second game of like a lower gas price challenge, where challengers can send a transaction with a lower gas price than the executor used. And the idea is that they basically, if they get included in a block within the buffer period, they've basically proven that the executor could have used a lower gas price. Therefore, they get the executor gets slashed and the stake gets redistributed to the challengers. However, if they do not get included within the buffer period, they haven't proven anything, so the executor basically used the current gas price and gets a payout. Should be reminded that all of this is just like to incentivize executors to act honestly. and it shouldn't always be used. Basically, you just choose a Dapp you want to interact with, you define some Dapp interaction triggers configurable to your users, you will use our standard, you register on the core by staking some ETH, you accept your user request through a front end and charge users according to your business model. Users don't need crypto, they can use PayPal. You keep your balance on the core above 0.5 ETH, and then the pay-as-you-go for the execution service is handled by Gelato Core, and now you basically have access for users to automatic triggers that will be executed by a decentralized set of nodes. Yeah, that's it.
Coming next is Viktor Radchenko from Trust Wallet. Viktor speaks about open source incentive systems.
So what we thought we wanted to solve, in this case, wanted to allow any blockchain in space to have integration into the wallet. And so we created a library that's called Wallet Core that allows you to implement all the basic functionality you need for the crypto libraries on the blockchain. So what Wallet Core is currently supporting is like 40 different blockchains. It has a way to universally sign any type of transaction. So imagine there's a use case where there's like so many different blockchains in the future, and you want to do a transaction from like Ethereum to Bitcoin, and there's a need to like sign transactions. So we have a universal way for anyone to sign those transactions as a protocol. So it's a small model, you pass information, and then you just sign it for you. And then Wallet Core allows you to compile all the code on all the different platforms. Because if you think about it, it's really important because it's not about just one platform that you can run code. You also want to think about like how you can run on iOS or an Android or even JavaScript. And then you want to make sure that the code you write is super small and it's lightweight. Mobile phones are a small operation system, so it's important to keep it small, otherwise people won't be able to download it. So that's kind of the idea behind it. And you want to make sure that the libraries you write always lightweighted and also implement in a low-level implementation, so it's super easy and fast to run it. And also scalable to many blockchains. So in the future, there's going to be so many different blockchains that everyone would want to build. And then we wanted to make it so easy for any other wallet who would want to build on top of it to integrate anything that's in the library itself. Yeah. At the same time, there's good incentives for the blockchain to be integrated with the Wallet Core, because imagine this, there's like hundreds of wallets or probably thousands in the future would want to implement some blockchain. So this means that every one of those guys would need to implement every logic by themselves, which is super inefficient. So instead you can have one library that does everything for you. And then all these projects, like imagine Libra or like Ton blockchain, they want to be supported on all the wallets out there. So instead of just going to every company and say like, oh, can you integrate us, here's the documentation, you can integrate it into the Wallet Core and all these wallets would be able to use it around it. So, and it's like plug and play libraries, so super easy to integrate into any wallets out there. And you probably know wallets are the interface for all the blockchains, so that's why it's super important to have like all these small modules. So with that, like, let's just build an API that allows me to observe any address and receive all the events that happens to this address. So imagine you building an app and then you want to see if there's any transaction happen on the smart contract, then you want to show this to a user. So that's kind of what this API does. You just specify a list of blockchains you want to observe and a list of addresses you want to observe. So in this case, you say like, I want to observe this, my address on Ethereum and this, Stellar account on the Stellar blockchain. So whenever there's a new transaction show up, it will just notify my webhook and it will provide all the information that happened. So you can build different bots. I'll show you some example where you can build in it, but you can think of it as an easy way to just get observers from the blockchain. And if you look at the space, not any wallet, like I haven't seen any wallets who even built this solution open source. It kind of sucks because like it's a really good feature, it will benefit everyone in space, but all this company keep it like private and don't make it open source for anyone. So if we think about this use case, like there's so much you can build on top of it, because if you know like when transaction happen on blockchain, you can just build lots of different webhooks that will notify your accountant there is any transaction, can you like do something for me? And you can do lots of different examples. Or you can even build a small bot that will say like, oh, there's an incoming transaction came to your address. And then lots of use case for smart contract execution. So imagine you want to see what happened to your order on like 0x protocol. So you can actually observe specific transaction that says, when trade is canceled, then notify me. And so whenever that happens, you'll get notified by the webhook. And then there's lots of use cases for like airdrops, dividends, payouts, and other different things. Yeah, so this is how we designed our interfaces for the block atlas, because I wanted to make it so it's applicable for a specific blockchain, because every blockchain will have specific use case. So some blockchains will just like store transactions, some of them will have staking, some of them will have collectibles. So it could be scalable for different sidechains as well. So as long as there's a way to communicate with the blockchain, you can just implement specific interfaces in Go. So this is just an example from Golang, how we define different platforms. By a platform means a blockchain protocol. And then we have this new block API interface that allows any blockchain company come in and say, I want to observe all the transactions that happen on this blockchain and then implement for the observer, the one I showed previously. So this is what we will do. You will just implement two methods and it will be available for anyone to use. So all it does, it just says like, here's my current block number in the blockchain and here's all the transactions or all the operations or events happen on the blockchain. So the parser will go through every block in the blockchain asynchronously, and then whenever it finds something, it will just notify all the observers that subscribe to the event. Yeah. Currently, Block Atlas supports over like 30 different blockchains. It's a little bit less than Wallet Core. We're still working on different integrations. And so whenever you want to add something custom, you can create a new type. Let's say it's not going to be token transfer, it's going to be eToken transfer. So this is where you can define all the detailed information, because with eToken, so you can have multiple inputs or multiple outputs. So in 90% of the use cases, maybe more like 95, you would always have from and to as the regular sent. And the rest is like multi-sig and all that.
But
so
you don't know what the change address is. What is the destination, what the change address?
You can know the change address. So ideally, the way you would approach it, you would need to know the XBOT in order to calculate what the change address is going to be. So the way we build a trust, for example, we use XBOT to calculate what the change address is going to be, what is the receiving addresses, and then we calculate what the next index is going to be. So ideally, yeah, like it's kind of limited, but at the same time, it's tough to work with the UTXO. So we thought, like, let's build something simple that will work in 90% of the use cases. So we provide the XBOT, and then it just gives you information like what's the to, from, and yeah, that's a simple solution, I guess, for now. But you can always extend this.
One of the best UX designers out there in the Ethereum Foundation is actually Alex van der Sand. You cannot pass from a presentation from him being unnoticed. Alex brings so much knowledge about how can people actually use a Dapp without knowing that are using a blockchain behind them. So have you ever heard about a meta transaction? How can people use Ethereum without actually paying gas?
With meta transaction, what happens is instead of your funds being kept on private key, private keys are just used as a signed message with ephemeral private keys. Like you use one and then you throw them away. And then you have a contract that verifies those messages and does something accordingly. And often that contract can be your target contract. Maybe it can be an exchange, maybe it can be a token, or maybe it can be an identity contract that is able to execute anything on the blockchain. And then anyone can deploy and pay gas. That's the magic of it. Because suddenly the private key that is signing the message is not the same that is paying for the gas. Who's paying for the gas? Anyone, really. Can be the Dapp, can be like a sponsor for the Dapp, can be the user themselves with another token. And because of that, the user can create as many private keys as they want and revoke as many private keys as they want. And then it's just one key per device, so it's safer. So let's talk about more detail on how that works, right? So first, I'm a designer, I'm not a developer, and people often think that the difference between like a design is the difference between that clock and the left clock. And it's not. Like good design is the difference between like having all those gears exposed and hiding all those gears in front of something. Which obviously means that a good design needs to talk with good engineering, right? They are the same thing. It is a conversation on trying to hide complexity. So how does it work, right? It doesn't matter what you do to your crypto app, and like you can put illustrations, you can put a bunch of things. That's what I call decoration, right? You can make your crypto app really look nice, but you have to do two things every time. One of them, you have to create a key, and then you have to put money on it, right? There's no way around it. Every time your users will be, like, be there for the first time, they will have to do that. You can like put it in pink and make it a nice and make an animation. Your user will need to do that, and those steps are already inherently confusing. And what happens if they want to install in a second device, or maybe a second app that is not you, or maybe like a laptop? So they can do the same process again, right? So they create a key, and then they put money on it. Of course, it's a little bit easier because now they already have money on the other app, but now they have two keys that they have to deal with, and now they have two keys with money on it, because like every time you move the money around, not only you're spending gas fees, you're always leaving a little bit of money behind. So I think that's a terrible user interface, right? You don't expect that when you install Twitter on your laptop and then Twitter on your iPhone, that's going to cost you money, and then you have like little bits of Twitter tokens around. That's insane. The second thing people often do is that they just duplicate the key. And then often they do it because of laziness, right? Look, I'm sorry, I'm not gonna write down a 12-word seed phrase for the third time. I'm gonna just be lazy. I'm gonna take my MetaMask seed phrase and put it here. Which is super practical, but it's terrible, because when you do that to a new app, you are just giving it access to all your keys for eternity. And there are even ways in which people do that, which it's not obvious that they are doing it, but they are. So for instance, often you see people who are creating a new way to log in, which is you take your username and then you use your password to encrypt it and hash it multiple times. That's also sharing your private key, right? See, even if you can create a private key out from a password and a username in a safe way, if you do that to two like different apps, you are still sharing your private key. It's a bad idea. No, don't do it. There's a third way some people are starting to do it, which is just keep the private key on a server, which can be non-custodial, right? Sometimes you can do it in a very non-custodial way, in a safe way, in a decentralized way, that like the server themselves don't know your private key, but still have the same problem. It's just one private key that has funds. If that server disappears, you better have a backup of your seed phrase, and when you start that, suddenly you have the same problem that you have a private key and then you have to share it with other apps, and then we are back to square one. And on the meta transaction world, like on this magical meta transaction world, what happens is that every device has its own key. And it's sort of, okay, it's similar to what they had before, but you notice that none of them have any funds on it. So where are the funds stored? Well, the funds are stored with our super giant robot there, right? What is this, right? What we're doing is that we are creating a smart contract account, and that's the one who creates your funds, right? That creates who holds your funds. And all your private keys are just access tokens to them, and you can revoke them at any time. And because of it's a smart contract, you can give them limits and say, hey, maybe that server, like you could even keep a key on the server, but maybe because it's a smart contract, you can say, look, I'm only keeping my key on the server, but I can only use my server key if I don't have if I don't have access to any others, right? Which is like a cool way of doing it. So I can like give you the key and you have access to it, but you can only use your key, like the bank can only use your key to key recovery if you have lost all your devices, right? So the bank cannot steal your money, or like the custodial can steal your money. And there's another thing the robot can have, ENS names, because there are some too. Right? What is an ENS name? It means that your user doesn't need to see a hex address ever, right? They can just have like my.name.if or something similar to that. And an ENS name is just a collectible, it's just a nifty. And so your robot can have nifty, can have collectibles, and can have a bunch of other tokens. And I think that's awesome, right? So I think every user should have their own ENS name, and I think you should give a ENS name to everyone.